All right, I'm ready now. Who had a question? Yes? Where is what? It's at the end of the chapter. I think I wrote this on the syllabus, so reading everything's good. At the end of the chapter, I said I didn't put page numbers because all the different versions of the book have different page numbers, so that got really exciting for me. So at the end of the chapter. Yep. If you just do the view book online, like I said the other day, you won't see the homework. For whatever reason, they're like, ha ha ha, I'm going to make you download the PDF. So, okay, we just deal with that. So you got to download the PDF if you don't want to get a physical copy of the book in order to see the homework. But it's always at the end of the chapter, not at the end of every section. They slam it all together. Is that cool? All right, I agree with that. It's a really important thing to know how to find the homework. So are there questions from the homework that you guys have definitely started because you know that's the best thing to do? Yes?
Can you kind of just go over how to find your
Yeah. Is there a specific problem you're looking at?
like number 44.
Yes. Okay, that's the one we're going to... Let me just start going over that little section of problems. So I know there's going to be questions on that. Oh, Totoro. Oh.
No.
Yeah. If you don't know Totoro, then I feel really sad.
Excuse me.
Life is not as full as it could be. So this is that section of homework. The very, like I think it was 1 through 5 in section 1.1, and then it went to 44 or something. You'll realize the book, they set it up in like practice section and then homework section, and I sort of disagree with that. It's like, I have to go from both sections just to get all the kinds of problems I want you to do. So that's why it kind of bounces between the lower numbers and the higher numbers. Okay, so you just believe me and just go through it the way I've got it written up. Let's take a look at... Go. Okay. So it's these problems here. If you've done the homework, this hopefully looks familiar. What did I sign? I signed 44, 45, 48. Is that right?
Yes.
All right, so let's do 46. Haha. So this one asks you to identify the population, the sample, the parameter, the variable, and the data. I think I listed one out. Did I lose one? Yeah. All right, makes sense. The statistic should be thrown in there. I like it. So population, sample, and then parameter, statistic. Those kind of go together. That's nice. And then variable and data. And it says give examples where appropriate. None of these tell you what the sample is, so you can actually just make up your own. You could be something as... so 46, what is the population in number 46? Voters is not good enough, because then I'm like voters from all around the world. There you go. So the best way to think about what the population is what pool of people will be picked from. So if you just say voters, no, I'm not picking from voters, I'm picking from a more specific group. I'm picking from voters in his district. So the population would be all voters in his district. So what would a sample be then, for example? Sure, a fraction, a subgroup. You could even, like I said, give examples. You could say 38 randomly selected voters from his district, right? That would be acceptable also. But you could do something just a subgroup of the people, of the voters in his district. How are we doing? That's more like a definition application directly. Let me stop there for a second. Everybody okay? All right. Let's see. The parameter has got to describe the Population. It's got to be numerical description of the population. So you can actually just use the exact same wording for part A. So what would the parameter be? What's the parameter? What is he interested in finding out? It's a key word. Proportion. He wants to know the proportion of voters who think he's doing a good job. So the parameter would be the proportion of all voters in his district that think he's doing a good job. So what would the statistic be? The proportion of the sample, but even better, just put the wording you use, proportion of the subgroup, or the proportion of the 38 selected voters from his district that think he's doing a good job. All right, let me stop there for a second. So you see how the wording of the population is almost the exact same as the wording of the sample. You just replace the word all with subgroup or 38, whatever your favorite number is. Because the population of the sample should be very similar, because where does the sample come from? The freaking population. So the description of the people you're talking about should be the same. It's just, are you talking about all of them? Population. Are you talking about a subgroup of them? Sample. Parameter references the population. Statistic references the sample. That's all. And normally, there's a good note to take. Parameter and statistic, they are normally either an average or a percentage or proportion. Those are the two main things we see as statistics, right? When I say statistics, normally people think percentages. 38% of people are going to vote for blah, 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 right? But another statistic is the average number of birds that fly through something. I don't know. What a great example, Jeff. Oh. The important thing there is it's an average or a percentage, right? Let me see. What else did they ask for? The variable. What did I say the variable is directly related to? The question you would ask. So what question would you be asking the people in the sample? Yeah, whether or not he's doing a good job. Variable. Done. And the data would be the answers you would get, so that's where you definitely want to just give examples. And of course, I mean, with the only possible data points you would get, if you strip out all the whatever, opinion, no, I don't think so because he did it. Okay, then no is what you're saying. So, yes or no. I love it. Now, there's a problem where it says the amount of time a client exercises in the center each week, so it could be 7 hours, 28 hours. You got a wide range, but this is a freaking yes or no question. So the data there is easy, just yes or no. All right, does that help? If you've tried this problem yet, if you haven't tried these problems yet, then you're not even aware of what the problem was. Yes.
We wouldn't say like qualitative or quantitative.
No, it doesn't say identify the type of data. Identify the data.
Okay.
So give a description of the data. I mean, what would, in this case, examples is what makes the most sense. Yeah. Is that good? I get the impression that you guys, a lot of you maybe haven't tried it yet. Some of you have. Maybe not all of you. And that's a bad place to be in math class right now, is to not even have tried the homework yet. I know it's the first week, but shit, the worst thing in the math class is to fall behind at all. So get ahead now. Anything else about these? Anything specific about one of the other ones? I mean, like, let's do one that's not a proportion, like 42. What's that one? A fitness center is interested in the mean amount of time a client exercises in the center each week. So what would the population there be? Clients of the fitness center. Good. Because clients, that's a lot of people. Clients of what? Okay, clients of that fitness center. That's the population. So what would the sample be? You can't find it. That's something else that throws people off. They don't tell you the sample. You got to kind of create it. Give an example of what the sample would be. So what's an example of what the sample would be for 42?
Clients are specific.
Huh?
Clients are specifically.
Oh, okay. So you could discuss the method of picking them, sure. But if I were you, I might stay away from that, because then that gets into questions about is that a good sample or a bad sample, and you just want to say here's a possible sample, assume that they're going to do it the right way, right? Does that make sense? I mean, don't bring in more problems than you have to, right? So, I mean, again, just like I said before, one way to say it is just almost by the definition. What would that be? The sample would just be a subgroup of all the clients, and or you'd be more specific. You could say 77 randomly selected clients from the fitness center. You guys, is that better? I mean, I understand this problem is a little bit wonky. The reason I didn't say anything about it on the first day is because this is the way I test to see if anybody's doing the homework at all. If I didn't get this question, I'm like, well, shit. Nobody's doing it because this question is freaky. You guys with me? Okay. Let's just go ahead and finish that one out. Where did I leave off? The parameter for number 42?
Amount of time, all the clients.
And parameter always has to reference the analysis you did. Is it a mean? Is it a percentage? Yeah, the mean amount of time that who?
The clients of the fitness.
No, the parameter. Parameter has to reference the population. Okay, see, I mean, that's the definition tells you how to put it together. The mean amount of time that all clients of the fitness center work out there each week, or whatever. Yeah, each week. You guys understand? I mean, that's the definition is more than just a definition. It tells you how to freaking do this problem. You have to make sure that your answer for the parameter references the population. So what's the statistic? What's
The amount of time for the subgroup.
yeah, the mean amount of time that the clients in the sample, and you can say the mean amount of time that the 72 or whatever it was I said, randomly selected clients work out each week. You see what I'm saying? You reference the population for the parameter. So where do you get that from? Whatever your answer to part A was, reference that group. And then whatever your answer to part B was, is when you answer the statistic, reference that group. I love it. I do love this problem. And you're like, you would, Jeff, but it just really forces you to really think about the definition, go a little further, and really try to come up with your own examples and so forth. I love it. What's the variable? Good, the amount of time, because what would you wouldn't say, what's the mean amount of time? No, you say, how long are you working out in the center? Right? Don't just say, how long are you in the center? Because if you've ever gone to the gym, there are people that work out for like 10% of the time, and 90% of the time is just socialization, which is fun. Yeah?
Can you repeat what you said for statistics? Like what the answer is?
Yeah, the statistic is exactly the same wording as the parameter. The parameter would have been the mean amount of time that all the clients of the fitness center work out each week. Statistic would be the mean amount of time that the subgroup of all the clients would work out in the center each week. Or however you answered the sample question, if you said 77 selected, then you would say the statistic would be the mean amount of time that the 77 selected clients work out each week. You have a little bit of leeway because it says give examples where appropriate. Cool. Maybe. Statistics, I know, it's kind of like people come in and they say, I hate math, and oh my God, and then we've thrown a lot of English into the math now too, right? And you're like, okay, wait a minute. But this is really just applying the definitions. But I like the way they do this. Did we get all the way through? Data would be what? I think I already said earlier, didn't I? Data would be 7 hours, 27 hours, 2 minutes. You know, somebody joins and like, just to say that, I got a gym membership. I work out there. 2 minutes. Oh, I'm done. All right. You guys, everybody cool with that? Everybody understand? All right, anything else from the homework stuff? Any other questions from homework? Which one? 48? Oh, this one. So it's the same idea as what we just were talking about. I'm trying to stay away from doing the homework problem specifically, but you do it exactly the same way we just did the other ones. It's a proportion now, so that word has to show up in your parameter and your statistic. The population, what would the population be for 48? Yeah, this one's a little bit weird. I like this. Yeah. Now listen. All right, this is a really good one. the population cannot be the people who will vote for a particular cause, because the answer to the proportion will always be 100%, because that's the only people I'm looking at. Let me let that sink in, because that kind of mistake I get all the time. The population can't be people who will vote for that particular cause, because then when you say what proportion of the people I'm looking at will vote, well, it's always going to be 100%. Always. What good is that? So what is the population? So that I would accept a couple different things. I would say, people who will vote, not just for a particular cause, but just people who vote. Yes.
People who can vote?
People, yeah, good. People who can vote, even likely voters, I would accept that possibility, because that's pretty much what they always poll as likely voters, so they get a little more accurate picture. There are people that have strong opinions, but they'll never vote, so that won't help predict elections then, if they use those people in there. All right, I do agree 48's a little bit more wonky, but I'm going to let you try to figure that one out on your own. Okay, anything else from homework stuff? Yeah.
Section 1.2, question 76, or something similar.
Oh, yeah, okay. I love it. Oh, okay, so this one's a little more open to some interpretation. I mean, it's 1936 presidential election. They thought that Alf Landon, like who the hell's that? So obviously they didn't win. Would win by a large margin. The magazine sent a survey, I guess, to approximately 10 million prospective voters. So it's going to ask you questions related to what the issues might have been. Yeah. Think about the state of the United States in 1936. Anybody know their history about 1936? What was happening in 36? If you're not aware, you can Google it. Right? Some of you guys need a class in Google just so you know how to search. I think a lot of times older people tend to think that younger people are going to be great at computers, and no, you're not. You're just not. You're not. Trust me, I've seen you try to Google stuff, and oh my God. Not all of you. I'm just being very blunt. Yeah, so how many people replied? 2 million, you'd think 2,300,000 sounds like a lot. But think about the people that would reply, that would take the time to reply. Is there something that might be similar about them? Or who are these people, probably? I mean, if you don't really care one way or the other and you sort of feel this way, you're going to reply? No. The people that feel strongly, and very often the people that feel strongly overrepresent one side or the other. And you should be very aware of this fact, living in the times we do. What effect does a low response rate have on the reliability of the sample? So it is a little bit open, but you should be able to figure that out. And then sampling error or non-sampling error. I don't know if you guys have read the book. Sometimes I'm going to leave certain definitions out just to force you to go back and look in the book, because the book exists for a reason other than giving you homework, right? So you have to go back and see, what does it mean? What's a sampling error versus a non-sampling error? Let's see what else we got here. During the same year, George Gallup. The word Gallup should hopefully sound familiar. Gallup poll. Anyone ever go to Gallup.com? No, it's okay. No political wonks out there. Anybody love politics and just eats it? No, I love it. Do you guys love anything at all? Do you guys?
I love class.
Okay, good. That's a good one to love. His researchers use a method they call quota sampling to obtain survey answers from specific subsets of the population. Now, what does that sound like? Quota sampling is an example of which sampling method? What does that sound like? Quota sampling obtains survey answers from specific subsets of the population. Okay. So maybe go back and just review the different types of sampling methods, right? Okay, is that cool? Okay, so this problem is a little bit of a Google problem, possibly, if you don't know your history too well, and a read the book problem, which, at least most of them is read the book problem. Anything else from the homework that I can help? out a tiny little bit? Okay. Which one? 82. Oh, so yeah, we haven't finished 1.3 yet, so we haven't talked about, let's see, what does this ask you to do? Oh, this is a frequency table. So we haven't talked about frequency tables yet, so we're going to do that today. Is that cool? We're going to talk about it today. Okay. All right. So we'll talk about that one today. Anything else from homework stuff? Yes?
Not like anything on the problems, but for like the homework, can I do like section 1.1 on the front and like 1.2 on the back?
Oh yeah, totally. I love killing less trees is always good. Okay. All right. So the plan for today is to continue. These are free. Some of you want to go up, some want to go down. To finish out chapter 1, and then we're going to get a little bit into chapter 2, and then we're going to end class a little bit early and take a little field trip around the campus. Oh no. Oh, they're there. Good.
I could put this forward and you could put the back part on here if you want.
I don't want you to feel pressured
Oh,
about
no, that's fine.
it falling off or something. Plus, it's got Google. It's got Gorilla Glass, so it can survive falls. So don't freak out if it falls out. Okay. Thank you. So really, the only thing I have left in chapter 1 to discuss is related to that question I just had. Guys. It's class happening. So, in general, if you need to talk about whatever, if you're expecting a phone call, whatever, sit near the door so you can get your ass out the room and talk about it, whatever. So that's fine. But we're going to, the only thing I have left to do in chapter 1 is the frequency table stuff. And I think they introduced this a little bit early, but I could deal with it. Let me see if you guys get this idea. Let me give you. So let me see. I'm going to do like a cluster sample. So you guys and you guys, Travis and you, everybody in those rows right here, are willing to tell me your age? Yes. Okay. 28. 18. 32. 17. 17. Oh yeah, the twins. It makes sense. 24. That would have really freaked me out. 24. 19. 23. 18. Travis. 32. 20. Almost legal. 19. 20. 19. 20. 18. All right. Broke the pattern. 18. All right. It's a young row. All right. So here we have data. We have ages. And it's a sample from the class. And it was a sort of a cluster sample. I didn't really randomly select the rows, really. We're going to make what's called a frequency table. So I'm going to list the occurrences of data. So 18 happens, right? And 17 happens. Let's start at the lowest one. 17 happens. 18 happens. 19 happens. 20. 21? Nope. What's the next one after 20 that happens?
23.
23. 24. 28. And 32, right? That's everybody? Think? So all a frequency table is how frequently a number appears. Either this number itself, or I could have a range of numbers and say how frequently does a number appear in that range. So I could have said from 17 to 20, and then from 21 to 24, and so forth. That's the next level of what we're going to do with this. Let's just start with this guy. How many 17s? 2. How many 18s? Looks like 4, right? How many 19s? 3. 20s? 1, 2, 3. 23. 1. 24. I think there were 2 of those, right? Right next to each other. There you go, Jeff. 28. 1. 32. 2. That's right. How many people did I talk to? 1, 2, 3, 4, 5, 6. Second? 18, thank you. And then 6, 12, 13, 14, 16, 18. Thank God. So when you're creating a frequency distribution, a really smart thing to do is add this up and make sure it's the total. You with me? Because if you don't, then everything's thrown off a little bit. Oh, shit. Thankfully, you have a teacher that gives you partial credit. So if you make this mistake, you lose a point. As long as you do the rest of it correctly, you're fine. Now, as a human, what's a little bit better than just pure numbers is percentages. So what we call this frequency is the pure numbers. The percentages are what's called relative frequency. And the reason we call it relative frequency is it's relative to the total. So it is just making fractions out of these. So the total was 18. There were 18 total people. So out of 18, how many people are 17 years old? 2 out of 18. It's like 0.11 forever. Do you guys know that 1 divided by 9 is 0.1 forever?
Everything divided by 9.
Exactly. 2 divided by 9 is 0.2 forever. And a lot of times people know 1/3 is 0.3 forever. Yeah. Well, 3 divided by 9 is 0.3 forever, and 3 divided by 9 reduces to 1 divided by 3. It's crazy. That's great. And then 4 divided by 18 is 2/9, which will be 0.22 forever. What would this be as a percentage? 0.111 forever. 11%. And then you can say 0.1. Just keep the ones going. So this will be 22.2 forever percent. Let me stop there for a second. Yes?
Where did you get the 2 divided by 18 and 4 divided by 18?
So in this class, the relative frequency is relative out of 18, out of the total number of people. How many are here? 2 out of 18.
Okay.
That's a fraction. I can make it to a decimal. I can make it to a percentage. So now this is more related to, this makes more sense to us, believe it or not. If you give me percentages as a human, I'm like, thank you for that. Because if you tell me about 30% do this, that's better than telling me 72 people do this. I want to know relative to everybody. How big is that group? So what about 3 out of 18 is 1/6 is 16.6 forever. So amazingly enough, another 3 out of 18. If you don't trust me, you can do the calculator. 1 divided by 18 is a half of 1/9. So that'll be, I think it's 0.05 forever. Is that right?
Yeah,
Oh, God, percent. 2 divided by 18 we already did. 0.11 forever, so 11.1%. Are you guys with me? I mean, now you see how it works. It's just, you keep doing it. There's another 1 out of 18, so 0.05. And then 2 out of 18 is the 0.11 again. And of course, what should happen with all these percentages?
Add up to 100.
At least close to 100, because you might round. Sometimes you might have to round something. So it has to be really close to 100, if not exactly 100%, or else you left something out. You forgot somebody. Poor little people. I like it. And this is a frequency table. And then when you add this, amazingly enough, it becomes a relative frequency table. So all relative frequency means is a fractional part. It's the percentage that is represented by that group. Let me stop there for a second. So nothing amazing computationally here. The next level of this would be to create what's called a histogram. We're not going to do that yet. We're not quite there. We will do that a bit later. Okay, let me see. Blah, 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 blah. So that's all I want to talk about in section 1.3. Just to warn you guys, I did leave you some stuff to read on your own. So don't say, you forgot to talk about this. No, I didn't. So reading the book is a good idea. I want to get into chapter 2 now, but anything left over from chapter 1? Yes?
All right, I just have a question about the reading. Do you just expect us to read the whole chapter, or are you giving us like key parts that we should read? Or... Okay.
I like it. So, yes, we have unreasonable expectations. As a student, what you do is you do as much as you can. You do the homework, and then when you hit a spot, you try to find that area and you read it. I totally understand that. Yeah, in reality, I love it if everybody read every word, but my God, that's a bit much, right? So I don't blame you if you don't read every word, but if you don't read any of the section, that's not good, right? So at the very least, look back for examples. And I will kind of do that on purpose. I will leave some stuff out of lecture, so you have to go back and use the book. Me plus book equals class. So there's a reason for both of us, thank God. Have you ever had a teacher that's like, they were a walking book? It's like, I had a chemistry teacher, I'd ask her a question, she said, well, just go read the book. And I'm like, what are you here for? So I will sometimes do that to you on purpose, just to make sure you're actually reading some of the book. Okay. So... the first chapter just set up, for the most part, terminology. How do you discuss statistical experiments, all the parts? How do you discuss the results? Chapter 2 is going to be how do you display the results. Right? So chapter 2 is going to be, once you have data, how do you display it to people? How do you show it? There's a lot of bad examples of showing data, my God. And unfortunately, some of them I've seen are created by statistics teachers. You know, real quick, before I move on. Since we have all this up here, let me just show you one little thing. This is not a true histogram, but... okay. Yeah, the corner of shame. So I can make... basically, what's a histogram? Let me show you how to do this. The scale here is a little bit wonky, but just to show you the idea, I'm not going to make the incomplete picture. But I could make a little 17, and I'm going to put a bar here, the height of which is going to be representing this. So I could either make the scale based on these numbers, but more often what's better is to make the scale based on the percentages. So how high do I want my scale to make it? 22 at least, right? So maybe 20. I like the people saying 25 because you're thinking ahead and saying a scale of 5 would make sense. So this is a skill that algebra should have given you that sometimes I see is lacking. Picking scale appropriately is not easy for some people. Try not to go up to 100 every time because then you'll have this picture that looks like, okay, here's my picture. There you go, 100. No, blow this up. Go only up to 20% if that's the highest percentage, right? Some of you guys are like, I can't believe you have to say that. Yes, I do. So here I can make a scale 5, 10, 15, 20, 25. Now, every class has its own little, I can't believe it's going to take points off for this, but you got to label your scale, your axes, right? So I'm going to call this one, what would I call this axis? What are these numbers? Percentages. Better term, statistical term, relative frequency. So this scale, this axis is always going to be real freak or just freak? Or relative frequency or frequency. Right. This scale, what's it going to be in this case? Ages, I love it. Ages of students. And my stats, blah, 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 blah. Okay. So 17, that bar, of course, would go up to just over 11%. You're doing it by hand, so I don't expect it to be like perfect. But dear God, don't go here or something. 11% should be just above 10, so that looks good. And then 18, would go up to 22, and you take it right off of this last one. Go up to about 22, bam, and then 19, so forth. You guys with me? No gaps. Because a gap would mean that there's nobody there. So like at 21, 22, there's going to be a gap because there's nobody there. Don't put gaps between them unless you mean there's nobody there. I like it. Let me stop there for a second. So I don't like necessarily that they put frequency tables in chapter 1 because it really kind of belongs more in chapter 2. So we're going to be doing a lot more of this stuff in section 2 too.
What do you mean when you talk about gaps? What
Sorry?
do you mean when you talk about gaps?
So you might think that you're supposed to have 18 and a half like this, right? You know, as you go up to 22. But this would be bad because it makes it seem like I left people out or there's nobody here. So you have a 17 bar that sidles right up next to the 18 bar. And there's only gaps when there's an absence of data there. I like it. Real quick note. What kind of data is this? Quantitative, I love it. Right? And then even more specifically, which one of the 4 levels of data would age be?
Cluster?
No, not sampling method, but which level of data, nominal, ordinal, interval, ratio? Ratio. Right? If, no, somebody who's 22 years old here? 22, there you go. So if you divide my age by your age, you get 2, which means I am twice as old as you. Yeah. Huh? 200%. All right. So this is ratio data. So what was my point with that? With numerical data, you don't want gaps. Let me make sure that should not be the way this is. There shouldn't be any gaps because the scale is an inherent scale. It's a numerical scale. When I do a bar graph, you've all seen bar graphs, and bar graphs are where the scale here is qualitative. Men, women, salary. Right. There's going to be a gap. How do I know I didn't leave anybody out? Because there's nobody in. It's men. It's women. I don't know if you guys get that. So if it's qualitative data, gaps are fine. Because that bar is known to mean just this person. Right? But the person who said that they're 20, are you exactly 20? Did you just turn 20 the instant I asked you that question? No, you're probably 20 point something. Right? So this width captures all that wiggle room. Okay, maybe. Okay. So with the same data, I think, yeah, sure, why not? I'm kind of glad I didn't do that. I was going to add myself in there, but 18 was a nice denominator to have. Let me go ahead and add myself in there now. There I am. So you'll see why I want to do that here in a second. The very first thing we learn in Chapter 2. Chapter 2, again, is all about displaying data. Not analyzing data yet. None of that. Just displaying the data in your sample. So this is my sample from you guys. And one of the very first, most basic things I could do is called a stem and leaf plot. I think this book just called, no, stem and leaf, I love it. Some books just call it a stem plot. I'm like, come on, it's much more interesting. Call it a stem and leaf plot. What the hell does that mean, Jeff? Well, this is only 2-digit numbers, but you can kind of see the idea how it can be extended. My stems would be 1, 2, 3, 4. So stems are the first number, and then the leaves are the second digit that comes off of those. So you can see why we call it stem and leaf. It kind of makes nice visual sense there. Possibly. So my stems. No Adventure Time before. 1, 2, 3, 4. And then as I do this, I can actually try to put it in order at the same time. So what has 1? Well, I see 2 17. So definitely write the repeats, and you'll see why here in a minute. You want all your data points to show up. And then what else we got? We got 18, 18, 18. Don't we have a 19, 19, 19? Did I lose an 18? Yeah. Got 4 18s, is there? 1, 2, 3. Why'd you erase that other stuff, Jeff? Oh, well. 1, 2, 3. that cool? So stem and leaf, it's remarkably simple. It's a quicker way to sort your data rather than just purely sorting. You sort by, like in clusters in a way. 20, what do we got? 20, 20, 20, and then 123, a couple 24s, and a 28. And then I got 32, is that right? Did I leave somebody out for these 4 people? Sorry, Jeff. That's the only 30 up there, right? No, there were two 32s, right? Yeah. And then 40 is just me. So, if you tilt your head this way, you sort of can see how things are distributed. Obviously, they are the way I would expect them to be. I know this is only a sample of you guys, but in a college introductory course taught in the middle of the day, I would expect a majority of the people to be pretty close out of high school, right? You with me? Sometimes, maybe some people still in high school, I don't know. Or they got out of high school quickly, I don't know. You guys with me? That's what I expect. This is definitely not what's called a normal distribution, a bell curve. A bell curve would mean small, larger, large, less, so they go up and come back down. This is not what we call normally distributed. It's not a bell curve, which is fine. Doesn't mean anything bad about it. All right, how are we doing so far? Stem and leaf, let it be nice. Now here's the thing. I'm not really done with this plot. I have to tell people how to read this. Because the whole point of this is to not show them the list of data, but just show them this representation. So I have to tell them how to read this. Put a little key. Key 1, 7 means 17. Because I could have this exact same stem and leaf, but my data could have been 2.8, 1.8, 3.2. Do you guys understand? If my data was 2.8, 1.8, 3.2, these would have been my stems, these would have been my leaves, but the key would have been 1.7 means 1.7, and then that tells me how to read the whole damn thing. Are you guys with me? Okay, I like it. Or it could even be 170, 180. Your key is going to explain what the numbers represent. I like it. Don't let that be difficult, because it really, really isn't. Sweet. Oh, sweet. I think I got... Let's do this. I did say 2, 2. It doesn't matter. I have a little group work sheet here. And if you desperately have to be, you can be a group of one, right? A little army of one. I would like you to at least get together one other person, you know. Especially the last problem is a little bit interesting to interpret, so we'll see if together we can. So just work on this sheet for a little bit, and then I'll stop you and we'll go through it together.
You're a little too high for me there.
I made enough of these. You don't have to take this.